Okay, now is stereochemistry to be considered? Well, of course, if we're going from 2D to 3D, that's just something that it's just like with your sp2 carbons to, doing nucleophilic addition, you're going to get an sp3 product, right? So going from 2 dimensions to 3. So this is when, your molecular modeling kits will still kind of shine in a good way. Think about regiochemistry here, all right? So magnetism, this is now regiochemistry, so we'll get into the other here, stereochemistry, in a little bit. Now, faster major product stereochemistry, if any. Okay, now we have an electron withdrawing group for our dienophile in this case. We have an electron donating group. So if we were to push some electrons down on this diene, remember there are two lone pairs about oxygen, push those electrons over. You're going to resonate between that and some charge distributed form. Okay, so positive, negative. Okay, so in other words, you can kind of think of this as partial positive, partial negative. Sorry, my Greek isn't totally on point here. I must have skipped the Greek life. All right, so in other words, if this is if you're thinking about this being net negative and then this net positive, you're on the right track, okay? Now, conversely, on the dienophile, you have an electron withdrawing group. So if we think of, our dipole going in the direction of NO2 or that nitro group, it's going to be electron withdrawing. And this is going to be partially positive, okay? So while you don't have any resonance structures to figure out effectively, this is going to be partial negative up here. So the positive with the negative is going to line up, and the negative with the positive is going to line up. So you're just going to see something like this form. Now, you may see, diastereomers of one another. You maybe see a mixture of maybe 4 different products. It really all depends. But we're just going to put it sort of generically as that for right now. Okay, we know there's stereochemistry here, but we'll get into that in a little bit. Okay, so now we have 2 slightly electron withdrawing groups here. Cl. So remember, now there was no stereochemistry with this previous one, but now there is actually stereochemistry. There is a cis dichloroethene dienophile. Sorry for the bump there. All right, we'll see the same sort of resonance structure or resonance structures for this OCH3 diene. Now, we're not really going to have any difference in terms of regiochemistry, but both of these are going to stick onto the same side, okay? Because that pi bond is going to reach out. Of course, another one is going to reach out and in a concerted fashion form those 2 sigma bonds. Okay. So if we have, say, this as a product. Now, if this were trans, and you would see, maybe this going out of the plane of the page and this sticking into the plane of the page, or vice versa. Okay. Now, what you are going to see is probably an enantiomer of this particular product, right? Because that OCH3 can either stick out of the plane of the page or into the plane of the page. Okay, and again, there's really no regiochemistry here because both of these substituents are going to be the same thing. So you're going to see the same effect. Okay, so next up, you're not going to see any regiochemistry here, although you are going to see some stereochemistry. Okay. Now, let's say we have, for our product again, push some electrons over. Oops. Okay, so we're going to get a double bond formation. Again, if these are cis, they're going to stay on the same side of one another. And this is going to be a formidable electron withdrawing group on both sides. Okay. Okay, so, and then you have this NH2 at the top, NH2 at the bottom. So, you know, these will be maybe sticking out or sticking in. So I could really just draw squiggly lines. Get the same thing. But remember, this is also a meso compound, right? So if you have an axis of symmetry here, you know, you can have actually a different product. Say if you have H2 Okay, so this is also a meso compound again. So you have an axis of symmetry there. But these two compounds are going to be different. Okay. All right. Lastly, so NH2, again, there's not going to be any there is going to be stereochemistry, but there's not going to be any regiochemistry to worry about because these both are the same. So really the one example that I had in the beginning is more of the regiochemistry example here. Okay, back to our problem. So I'll just put that squiggly line of NH2, again representing the racemic mixture RRS. Okay. Once again, just sticking these out of the plane. Now these could go into the plane, right? But we're really looking at what's with respect to that double bond as well as what is with respect to that NH2. Okay, so why don't you guys try 24.44 on page 1239. I'll pause this and give you about 5 minutes.